Hello again. Let's continue the party here. So, in a previous video, I shared my concerns about Helm charts and why didn't we create Helm charts to support the Apache project what we worked on. But there is a very similar question about Kubernetes operators. So we asked multiple times that why don't we have an operator? And let me explain my concerns about operators as well. So first of all, Kubernetes operator is a wonderful design pattern, and I really like it. And I think this is one of the power of Kubernetes, that even internally it has very similar things like the operators. But by default, I have just a Kubernetes server, right? And let's say I don't have any operator, but I have a huge list of YAML files. Some people don't like the YAML files, but I really like the YAML files because this is a really WYSIWYG system. What you see is what you get, right? If I deploy the YAML files, I clearly know what is expected from the Kubernetes server. All of the YAML files can be even committed to Git repository, use GitOps, and so on. So what about operators? Let's say I have an operator. Operator may or may not create YAML files, or not YAML files, but Kubernetes resources, right? So it shouldn't be a YAML files, but some kind of Kubernetes resources. But this is an internal thing. I couldn't control it anymore. What I can control is the custom resource, which is usually registered by the operator itself, and I can create, with other YAML files, just some kind of simplified custom resource. And as a result, the operator will check the state of the cluster and will eventually deploy something on Kubernetes or change the state of the cluster. And what is the problem with this one? Well, while I had the control on this side, I had the power to do whatever I want. But if this operator does it instead of me, then I have a limited control. I can control only this custom resource, and this operator and resource generation is not under my control anymore. It not always true, obviously, because there are different type of operators. So usually there are two main categories. One which just tries to make easier to install something, like a Ceph cluster, basically because the original project couldn't be very easily installed in a cluster. But if I have a project which can be installed in a Kubernetes cluster because it's cloud native, I may not need such kind of operator. The other type of operator, what I really like it, where it's not just installing something, but doing some kind of action, like a Spark operator which deploys or creates a new job in a Spark cluster, so which is running here in the Kubernetes and it does something, not just install something. So that can be very useful. The other question is that do I really need the runtime state of the cluster? Because if I wouldn't use anything, just generate Kubernetes resources under the hood to make it easier to install, then I can create it even offline and just use GitOps. To be honest, even for a cert manager, I think in some cases it can be better just to generate the certs offline, even if it's a dynamic SSL certificate, and eventually deploy it somehow instead of using an operator. But depends from the use case. Because there are the questions that, okay, what is the state inside the Kubernetes? How can I move from stage to prod? Is there any state which is managed by the operator? Because in that case, the state itself should be migrated as well. And how can I be sure that the final generated resources are fine? How can I customize them? How can I monitor them or check them? So it doesn't mean that all of the operators wrong, just we didn't need the operator for the simple use case just to install a storage system in Kubernetes. In some cases, it can be very useful, like doing some action, starting new jobs. So there are a lot of use cases, but I have some concerns to use the design pattern in all of the cases without any consideration.